Hello, everyone. Welcome to our Automotive Data Security and Privacy webinar presented by Omnex. We have a few things that we're going to be going over before the webinar, and we are going to wait a little bit for a few more people to sign on, and then I'll be presenting Mr. Juan Pimentel. I think we're getting more participants joining in. Okay. All right, I think we've waited a little bit, so let me go forward and say welcome everyone to the Automotive Data Security and Privacy webinar. I want to introduce Mr. Juan Pimentel. He's our principal consultant for cybersecurity at Omnex. He's on the U.S. Technical Advisory Group for ISO 21448, and for all of you, that's SOTIF, or Safety of the Intended Function for Vehicles. Juan, why don't you start the webinar and introduce yourself as well?
All right. First of all, to double check, do you see my screen?
Not yet. Let me stop sharing. Can you share yours now, Juan?
Okay. How about now?
Yes, we can see it.
All right. Let me put this in presentation mode. Give me feedback if you see the entire screen now.
Yes, now we're seeing it. Can you make it full screen?
Sure. How about now?
There we go. Yep, perfect.
All right. Yes. Good morning, everyone. My name is Juan Pimentel, and I am pleased to conduct this webinar on automotive data security and privacy. I've been with Omnex for a few years, and I've been working in the area of functional safety and cybersecurity for many years. Prior to working with Omnex, I was a professor at Kettering University in Flint, Michigan, teaching classes on computer engineering and electrical engineering. I have a wide experience in functional safety and cybersecurity, not only in automotive, but also in other industrial areas like process control systems, oil and gas systems, chemical industries, having worked for many years in the Middle East, particularly in Dubai. All right, so this particular one obviously is about automotive. Before I start the seminar, let me give you a little bit of history or a story actually about this particular webinar. This topic came about from an actual project that we worked few months ago, actually, with a customer, okay? And the project was very challenging because it involved functional safety, SOTIF, cybersecurity, data security, and privacy. Obviously, we had several consultants in the project, and the one area that we lacked consultants at the time was privacy, because automotive privacy considerations is fairly new in the automotive area. There are many privacy experts for IT, but not so much for automotive, particularly with the design component. So we obviously decided to look for a consultant, for an expert. And we interviewed a few people, although there were experts in privacy aspects, but they were not experts in the area of automotive privacy. So the project kept going, and at the end of the day, basically myself, I ended up performing the particular function. All right, so in the process, we learned a lot, and this particular webinar is mostly about lessons learned and also going back and explain to you some aspects of the project. Obviously, I am only emphasizing the data security aspects and the privacy aspects. there were other aspects that I'm not emphasizing in this webinar, which is the cybersecurity aspects, the functional safety aspect, and the SOTIV aspects. All right, so with that, let me go over the agenda, which is basically what you see here. After I talk about the goals of the webinar, I will explain to you the case study that I actually wrote in order to explain this webinar. This case study is because we cannot use the actual project as is because of confidentiality reasons. So we have to, make it independent from the actual project. So we decided to use to write a case study. And then we'll talk about particularly the main tenets of this particular webinar, which is data security and privacy and the privacy aspects. We'll concentrate on the properties and also on the threats. I'm talking about the security properties. And then I'll explain to you two methodologies that we ended up using a lot in this particular study or project, which is Stride and Lindum. And then I will explain how we use the methodologies for the case study. And obviously at the end, we'll draw some conclusions. First of all, you have probably heard or know about GDPR, which is a European regulation for privacy. And this slide basically shows, as you could see, the highest fines last year that the European community was able to impose upon companies. You see companies like Meta, TikTok, WhatsApp, and as you could see, the fines are quite large. So this illustrates to you that this is very serious. If your company is not meeting these privacy regulations, there's a very good chance that this company could be hit by large fines, as you could see. We're talking about automotive, not so much IT. So in automotive, you have several types of data, and this slide tries to illustrate to you the several types of sensors that are generating data on the one hand. On the other hand, it gives you also a pretty good idea about the sizes of this particular data. By far, the cameras are the ones that generate the most data. As you could see, about 3,500 million bits, typically. Number two will come LiDAR, which ranges between 20 to 100 megabits of data. And then would be radar on the left side. And then you move to the right side, you have other sensors related to the IMU, which is the inertial measurement unit. So in here, you have like a GPS or improved GPSs. And also below that, you have also ultrasonic sensors that generate very little data as compared to the sensors on the left side. So to begin with, as you could see, we have the fact that in a modern car, especially if this car is for automated driving, you have several sensors that generate tons of data. Secondly, there's several aspects of this data. For instance, where is this data generated? Is it generated inside the car or outside of the car? Another important consideration is the data flow. The data flow is particularly important for this particular webinar for the security and privacy, as I will point out later. You have data flows that the flow of data actually stays within the vehicle. Examples of that are the sensors that I just talked about, and also additional devices that I believe are becoming very important in the future, like EDR, which are electronic data recorders, and also a new family of devices that are just coming out based on this IEEE standard 1616.1, which is a standard for data storage system for automated driving. So these are brand new requirements for automated driving that will generate tons of data. So those kind of devices keeps the data inside of the vehicle. However, you have also data that's intended for outside of the vehicle that goes to the cloud or even data that's just in transit. What that means is that they're in processing areas and processing farms, if you will, in between where the data is generated or the data will actually end up residing. And then you have another issue that OEMs are particularly concerned about, which is the data crossing political boundaries. And this happens when you have data that needs to be sent to other countries, for instance. This slide shows another depiction of the data flow that I just talked about earlier, starting from where the data is generated on the left side until where the data is consumed by consumers. And as you could see, in between, you have several processing stages, okay? And on the top, there is a just statement indicating to you that not only cybersecurity, data security, and privacy are very different, pointing out basically that data privacy is all about the control that one has over personal information. Okay. The type of processing that could happen, as you could see, is first of all message decoding, meaning that the data is typically sent over communication networks. Another one is to be able to store the data in some kind of device or memory. Another one is the data treatment, and data exposition will be two examples of data processing in general until the actual is actually consumed by the end users. This one is another example from the viewpoint of IoT, Internet of Things, talking about protocols like HTTP or MQTT, which are very important protocols for the Internet of Things, which is a complementary technology on top of the vehicles. So as you could see, data generated by vehicles typically uses IoT technologies in order to send the information to either the cloud or to other areas until it's actually consumed by end users. Again, you see another version of the type of data processing and type of data flows in this diagram combined. As you could see, you could actually have several types of clouds, okay? One that's basically a container with an API, another one which you record events, and still another one that has to do with connected cars, basically services, okay? So again, this diagram illustrates the various types of data processing and the various types of interfaces that are available for this data on its way from the source to the end consumers. The remaining portion of this webinar, I'll talk about why is this important. And the reason is that, as you probably know, we have a lot of innovation in automobiles that are good for some features for some reasons. However, they also pose serious issues. The issues relate to safety, security, and privacy. Also, we know a lot about cybersecurity, data security, and privacy. However, the knowledge and experience is very generic at a very high level. And there is not much information or experience in terms of new product design. In other words, whenever you design a new product, you have these security and privacy issues from the viewpoint that you actually need to design a vehicle that would take care of these particular requirements. So this is what I mean by we don't know really too much about new product designs. Also, privacy is not the same as security. I think I pointed out before, and this will become clear later on. Privacy is particularly concerned about the so-called PII that I alluded earlier, which stands for Personal Identifiable Information. So this study that's based on an actual project, as I said, had basically three major goals. First of all, to discuss the particularly data and privacy, because it is not usually discussed in the context of vehicular systems, particularly in new product designs. Secondly, we wanted to apply standard methodologies, which are called STRIDE and Linden, for data security and privacy, respectively, in this new product design. And lastly, to discuss these data and privacy implications on current international standards, particularly ISO 21434. Okay, the tenets of the paper, again, is systems engineering, new product designs, and standards. And this is because, as I mentioned before, there is so much information and knowledge already out there on security and privacy. However, the information from this viewpoint that I'm showing here is fairly new. There isn't too much information from the viewpoint of systems engineering, of new product design, and from the viewpoint of current standards. Particularly, if you take a look at the systems engineering, you have the V model that I will go over quickly in the next slide. In the new product design, we're particularly interested in deriving requirements. I'm talking about design requirements so that you could, as a company, in conjunction with your suppliers, you could actually implement these requirements and design the product to meet these particular requirements. And obviously standards are well known because they are the state of the art in applying the security or privacy requirements. In the context of the system engineering, the V model is very important. And this one is used extensively in standards such as ISO 26262 and also 21434. In addition to that, the systems engineering requires that you really have a system thinking. And in terms of this V model, we're talking about primarily requirements that need to have bidirectional traceability. In other words, you derive the requirements on the left side of the V model, and on the right side, you're talking about testing, verification, and validation. However, anytime you do the testing, verification, validation, you need to have traceability to the original requirements that was defined on the left side of the V model. So one of the topics that I will concentrate in this particular webinar is the requirements, the elicitation of requirements. In other words, how do you come up with requirements? Okay, so I will illustrate that using the methodologies for data security and privacy, as I mentioned earlier. So another way to explain this is that we're primarily concerned about deriving requirements for data security and privacy. This slide will illustrate the main differences or the characterization between cybersecurity, data security, and data privacy, so that you have a pretty good understanding that they're not the same. There is some commonality, some similarities, but they're definitely very different. To begin with, for instance, the context for the assets, for the security assets, is quite different. In cybersecurity, that context is the item definition. And I'm sure you know, if you've heard about it, it's well defined in the standard 21434. For data security, the context is a data flow diagram. So you're concerned about data flows. You're not concerned about items the way it is in 21434. And for data privacy is the same. So the context for data privacy and data security are DFD, the flow diagrams. The threat model, they're also quite different. In cybersecurity, you have a threat model based on CIA, which is the standard properties for security, which means confidentiality, integrity, and availability. The threat model for data security, the well-known is STRIDE. I will briefly go over that soon. And in data privacy, it's called Linden. Okay. STRIDE and Linden, they reflect the first letters of the corresponding threat models that I will explain later on. In terms of regulations, as you could see, there's also quite different. for cybersecurity, particularly automotive cybersecurity, you have the United Nations Regulations 155 for the management systems and 156 for the software updates. In data security, as you could see, there are a couple of areas here that are very important. The first one is PCI DSS, which is a industry standard. It's really not a regulation standard, but it fills the void between a standard and a regulation. It's very widely used, and it stands for the card industry, the credit cards. It's a data security standard that industry sectors are pretty much relying on everybody else to implement this particular standard. So it acts like a regulation, even though it's not a 100% regulation. And then the other three are actual European regulations: the Cybersecurity Act, the Cyber Resilience Act, and also the so-called the NIS directives from the European Union. For data privacy, you have regulations such as the GDPR, the General Data Protection Regulation, and also the CCPA. Obviously, the first one is the European, and the second one is the American, particularly for California. In terms of these regulations, obviously, I'm not being very exhaustive here. These are probably the most important ones, the typical regulations, and there are a few other ones that are also important. These ones are particularly important for automotive. So the context is automotive. In terms of the focus in cybersecurity, data security, and data privacy, the focus in cybersecurity is the functionality of the vehicle. In other words, you're really concerned about what security violations are involved when you look at the functionality of the vehicle. In terms of data security, you're not concerned about the functionality. You're mostly concerned about the data flows. So you're talking about generic vehicle data that are involved in the data flows. Whereas in the data privacy, again, you're still looking at the data flows, but you're focusing on the PII, okay? So hopefully this slide will clarify to you the characterization of cybersecurity, data security, and data privacy. The case study, again, is a simplified versions of the actual project that we work with our customer, and it's an ADAS design. And if you know about ADAS, you probably are very familiar with some of these features. We're looking at features like highway assist, which is basically lane centering, ICC for intelligent or adaptive cruise control, ALC for automated lane changes, LKA and AEB are kind of reactive features, keeping the vehicle to help the driver to keep the vehicle within the lane, and also braking in a emergency basis. On the right side, you have the typical controllers associated with this ADAS. You have an ADAS controller, you have a parking controller, HMI controller, and also a vehicle gateway to interface to other areas of the vehicle, like cellular communications, Bluetooth communications, and OBD. Typically in a vehicle, it's complex because you not only have different protocols. In this case, this particular case study has a FlexRay communication, Ethernet communications, CAN high-speed audio and video communications, and CAN FD communications. So as you can see, you have several types of in-vehicle communication networks that are used for this particular case study. The data flows are important, as I pointed out before. I'm just going to show you a couple of data flows. This one is between the cloud and the actual sensors, going between the controller and the cellular communications, depicting two flows. One is MQTT and the other one is HTTP. These are the IoT protocols that are complementary to the in-vehicle protocols. This other data flow is concerned about a actual cellular phone that are used mostly for parking applications, okay, and the other controllers. and other sensors. This particular webinar does not talk about the parking applications, which is different. So this particular data flow is not considered in the webinar. All right. So let's talk about the two main models. I mentioned there are two main models, Stride and Linden. Many of you are probably very familiar with Stride. It's used a lot in data security. And Stride is short for, as you know, spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, which are the major threats that this particular model is trying to work with. In the middle column, you have the related, or say the properties. So you could take a look at it from either the threat, which is the negative things, or the property, which is the desired things that you want to achieve. It's one or the other one, it's complementary. And then the right side, you have the meaning of what that means. For instance, spoofing, you're trying to impersonate something or someone else in order to do something. And the property that you want to display to counteract this threat is authentication. And the same thing goes for the other ones. For tampering, you have the property for integrity, okay? And this one, the meaning is that you're trying to prevent someone else modifying the data or the code in the information. And the same could be said for the other threats or alternative properties. So there are two views of the same thing, okay? Later on, I'm going to explain this in the context of Stride. Sorry, this is Stride Linden, which is the basic focus of this particular webinar. So I'll try and move to it. So this one is the privacy property, and this one is the privacy threat of the Linden. First of all, Linden stands for the first letter of the threats, as you could see here. And the threats are linkability, identifiability, sorry about that, non-repudiation, detectability, disclosure of information, unawareness, and policy and consent non-compliance. The corresponding properties are the negation of that, unlinkability, anonymity, plausible deniability, undetectability, confidentiality, content awareness, and policy and content and consent compliance. As you could see on the right side, you could read what that means. And basically, for the property is that the meaning is that the intent is to hide for unlinkability the links between two or more objectives. It could be actions, identities, and pieces of information. For anonymity, you want to hide the subject's identity or the link between the identity and the actions or piece of information. For plausible deniability, the property is that there is the ability to deny having performed something, an action or something related to an action, piece of an action. In undetectability, you want to hide the subject's activity regarding that particular data. The confidentiality, you want to hide the data content. The content awareness, of course, you want to ensure that users are aware of their personal data and that only the minimum necessary information should be sought and used. And the compliance aspect for policy and consent is about the data controllers. You want the data controllers informing the data subject about or whenever the private policy or allowing the data subject to specify consents regarding compliance with a certain legislation. So in terms of the threats, these are the possible problems that you want to, of course, to address. So in terms of linkability, for instance, what you want to do is basically address the fact that an adversary is able to link two items of interest. So the same thing could be, or similar things could be said about the identifiability, non-repudiation, detectability, and so on and so forth. So again, in summary, as you could see, I showed you two sides of the same coin. This side is the threat, this side is the property. the meaning about these particular threats or properties and the goals of the system in terms of the privacy. Again, this is all about privacy. As you could see, there is a similarity between these privacy properties or threats and then this data security from the STRIDE methodology. And then, even though I'm not showing here, but you could compare this to the properties of cybersecurity, which are basically CIA, confidentiality, integrity, and availability. So with that, let me move on and talk about the privacy methodologies. The privacy methodology is on the left side, but actually on the right side, you have the data methodology also, which is STRIDE. And we're going to compare this. To begin with, as you could see, the STRIDE is a bit more detailed, has 9 steps. The Linden has 6 steps. However, one must say that the reason for this is that in the STRIDE, they emphasize few the steps in a bit more detailed fashion. The end result or the end goal of these methodologies are really the same, meaning that what you want is to identify the threats. You need to do a assessment of the threats with some kind of a risk method. And then at the end of the day, you want to address these threats using requirements and using solutions. In the Linden methodology, these solutions is called privacy enhancing solutions. In cybersecurity, we use the term simply controls, cybersecurity controls. So these are the controls, okay? Note that in the STRIDE methodology, they use a different terminology. It's called mitigation. So again, even though the goals are the same, even the notation and the nomenclature is quite different between these 3 areas of cybersecurity, data security, and privacy. So as long as you overcome the differences in terminologies, the goals are the same. So the STRIDE, as you could see, is the methodology begins with defining scenarios, gathering external dependencies, listing your assumptions, and also because remember the data flow diagram is particularly important. So steps 1 through 4 is really setting up to really clarify and characterize your data flow diagram. So step 4 is about external security nodes, external to the data flows. Step 5 is the major one, is to create the data flow diagrams. That is very similar to step 1 in the Linden methodology. So one way to think about this is that the Linden basically begins with step 5 in the STRIDE methodology. Okay, it doesn't have too much preamble as compared to the STRIDE methodology. So if you move forward in terms of the STRIDE, after step 5, you have determine the threat types, identify the threats to the system. So what you're doing in 6 and 7 and 8 actually do a threat assessment, basically, and also a risk assessment. And the last one is to mitigate the threats, which is fairly short, whereas the Linden methodology is a bit more detailed in terms of step 9, okay? Because in addition to defining the DFDs in step 1, step 2 is to map these privacy threats to the DFD elements, okay? So this is more explicit than in the STRIDE methodology. Step 3 is to identify misuse case scenarios. And then 4 is about the prioritization. This is about the risk evaluation, basically. And then step 5, very important, is to elicit the privacy requirements, okay? Because these requirements will be used for the design portion. This is how you design the system, okay? In 6, you select it's so-called the privacy enhancing solutions. What I said earlier is that basically this is the controls, the cybersecurity controls or security controls. All right, So this is the Lindo methodology on the left side then for privacy, and the Stride methodology on the right side for the data security. All right, let's talk about let me show you this diagram first, and then I'll go back to that one because it shows the same information. This one is in a diagram format. This one is in a table format. So what we have here is the data flow diagram for the ADAS case study. And as you could see here, you have the data flows in terms of a notation, which is notation from DFD, like the rectangles are entities, the semi-circles here are processes, the parallel lines is storage, and the blue lines are arrows or are data flows. And then the dotted lines are boundaries in the system. So the boundary of the system here would be equivalent to the item definition in cybersecurity, by the way. So the user and the perception are external to the item, so to the boundary in this case. And the boundary has three processes, and as you could see, several data flows. Some of these data flows are bidirectional, some of them are unidirectional, and they're actually labeled so that it's very clear to identify very precisely one of them. For instance, the E2 data flow is the data flow between the cloud database going into the cellular service, whereas C1 is the other way around, you know. So the direction with the flow is very important. Okay, I mean, not in this particular nomenclature, then this table shows the same thing. You have the elements. The elements are the entities. We have two entities, the perception system, the user. We have the processes. We have three processes. We only have one data store at the cloud, and then we have a bunch of data flows, which are shown here, like A, D1, D2, C1, C2, E1, and E2. All right. This was steps, basically the beginning of the methodology. Here we show steps 2, 3, and 4 of the Lindo methodology. And this step, sorry, has to do with the mapping of the Lindo threads to the elements of the flows. The elements are on the left side. As you can see, we have a bunch of elements. On the right side, you have the Lindum threads or properties, whatever you want to look at it. And together, we identify the so-called misuse cases. The stuff in dark blue means that it's not applicable, so we don't have to concern about that. The stuff that has X's means that they are applicable, except that the risk assessment method, which I'm not emphasizing because of lack of time, basically, means that this is low risk, so I'm not concerned about those. And the ones that are relatively high risk are the ones that are labeled A, B, C, D, all the way up to L. There are 12 of them. This step, by the way, if you're familiar with 21434 or would be equivalent to CALS or in other words, to the risk levels. Okay, so a risk level A is the use cases. Is embedded into this particular one. So because here we have already excluded the situations or the use cases that have very low risk. I'm only concentrating with the use cases that have high risk. So again, we have A through L, and let me point to your attention only to A and C, which is detailed in the study that is available from Omnex that you can request. And the details I will show only for A, for the use case A, okay? So as you could see, use case A is the linkability property associated with the perception system. What that means is that if you take a look at the data in a perception system, the question is, are you able to link any of that data to any users? So that's the context here, okay? And the result of the application of steps 4 and 5, which is basically the requirements and the controls, okay, are shown in this particular slide. So first of all, we were able to elicit two threats corresponding to misuse case A, which is on the top here. Okay. Remember, this misuse case A has to do with the linkability of data pertaining to the perception system. So what can we say about this? Well, there are two threats. Number one is that the data entries in the perception system can be linked to each other in a way that would reveal some person's identity. That's the basic nature of the linkability. Okay. The other one is that the misactor or a misactor can build a profile, for instance, of the user's driving activities using GPS location, okay, places visited, interest. So this profile can be used later on to identify this particular person. So those are the two threats. The corresponding design requirements is then, for the first one, is we need unlinkability of the data collected by the perception system. So that's one requirement. The other requirement will be the protection of the perception system per se in general. So the first one is very specific. The second one is a bit more generic, protecting the whole perception system in general. The corresponding design controls are that you could use data anonymization techniques on PII-related data with the perception system. And the other one is to enforce data protection by means of relationship-based access control. The access control pertaining to the perception system, of course. So as you could see, we use then this model to elicit not only the requirements, but also to design the controls pertaining to the linkability of the perception system. You could use the same process, the same idea for all of the other properties of Lindom methodology, and also all the other use cases pertaining to the other elements of the case study. So with that, then you will have a really complete set of requirements and design controls that you actually go and implement, because if you recall this case study, we're talking about new product design. Then you could decide, for instance, I'm going to implement those controls in the ADAS controller, in the HMI controller, in the gateway, or the parking controller, although the parking controller doesn't pertain to this study because we're not dealing with parking. We're dealing with the other features shown in this left side on this table. All right. So hopefully then the methodology is clear. The methodology is very generic. And this methodology was very good for our case because we use this methodology towards the end of the project. At the beginning of the project, we used other techniques, and we were not very happy with it because they were not very generic, and we were not able to really have a great confidence in that we had a complete set of requirements and a complete set of controls for this particular design. So one advantage or one good point about this Lindom methodology, and I will summarize that later, is that it is a very formal way. It is a very unique way so that you could able to come up with requirements which are high level to low level and are complete requirements, because you're paying attention to all the threats or all the properties of concern for privacy. Okay. In terms of standardization, the one standard that we used a lot in the project that we worked with our customer was 21434, obviously, which is a basic standard for automotive cybersecurity. This standard, unfortunately, does have something about privacy, but it's superficial. It doesn't have too much. The only thing it does have is what you see here, okay? Privacy is one of the damage scenarios impacting, when you do the risk assessment. The other ones being safety, financial, and operational. So the bottom line is that in 21434, we could not find any detailed information that could be used for our project, for our design, at the design purposes, whereas the Linden methodology provided the information that we needed. Okay, so this study then warrants that the Linden methodology should be used in new guidelines or maybe incorporated into new standards. As a matter of fact, I am proposing that the new version of 21434 does include, okay, an appendix or this methodology for, I'm talking about the Linden methodology for privacy requirements. The 21434 has a table in one of the appendices that clarifies the meaning of the impact rating for privacy. And as you could see here, you have 4 particular classes for that: severe, major, moderate, and negligible. But this is all in the 21434. In addition to this, there is no further really guidelines from this standard in terms of privacy considerations. And this is why this particular study was made at Omnex to help this particular topic, not only in the standardization, but also dealing with customers. So in terms of summary and conclusions, then, there's a lot of work and knowledge available on cybersecurity, security, and privacy. However, very little is known in automotive, particularly for new product designs. In fact, to the best of my knowledge, this particular study was the first one that was using the Linden methodology for new product designs. Okay. Stride is not new and has been used a lot, obviously, but the Linden for new product design, to the best of my knowledge, is new. Okay. So in this webinar, we address data aspects and privacy aspects that arise when you design new vehicles. So this particular study or this particular webinar, as you could see, is really applicable when you at the design phase. The detailed data security and privacy goals, requirements, specifications can be elicited using these 2 methodologies: Stride for data security and Linden for privacy, for data privacy. The current standards for new product design in terms of security, for instance, 21434, do not effectively support data privacy and also data security. And we are, at Omnex, we're taking steps that this will happen in the future. So with that, then, thank you very much for your attention. And at this point, I'm going to see if there are questions. Okay, so give me a second here to go over to the question and answer. Okay, I don't see that anybody has posted any questions. Okay. At this point, then, or Mike and Andrew, maybe you were able to somehow view if any questions were posted or raised by the participants.
There's one question now, Juan.
Oh, there's one question now. Hold on, let me see. Oh, yes. Okay. The question is, will you be sending this copy to the attendees? And the answer is the policy of Omnex, yes, we do make available this presentation in PDF format, but you have to go through our website. Mike, do you have any information about that? Or Andrew?
Right now, I do not know.
Okay, what I'm going to do is in the chat window, I'm going to write down the, or actually, you can do that, Andrew, could you write down your email so they could send you an email and then you provide the answers when we know the way that they could get the copy of this presentation? All right. So here is a clarification of the policy. Sorry about that. So what happens is that since all of you are registered, OnNext will contact you and they will give you a chance for you to request a copy of the presentation. Okay, so that's the process. So there's another question here. It says the definition of the term seems very confusing to me. Are you talking about the terms that are used for the threats? Okay. Yeah, you're not the only one, Dean. I noted this a little bit in my presentation. Unfortunately, when you move from cybersecurity to data security to privacy, yes, the definitions of the terms are not uniform, and there are some discrepancies, not only in the meaning, but also in the way they're defined, and even the terminology. They use different terminologies. Unfortunately, there is not a good answer for that one. I don't believe there is a standard that clarifies all of that across the board. The only thing I can think of is that as we get more experience in these particular topics, we have a kind of like a dictionary to correlate the terms in cybersecurity and data security and privacy. Okay. There's another question here, Omnex. Okay. So I answered that question already. All right. I don't seem to have any additional questions. So with that, let me just say that, again, thanks for your participation. As I said earlier, Omnex will contact you, and whenever you get the contact from Omnex, you'll have a chance to request the copies of presentation or any additional information that you may want about this particular webinar. Okay, so with that, thank you so much, and good morning.